Now okay?
Yes, yes, yes.
Can we go? Okay. Ladies and gentlemen, now we are going to the first technical talk in this workshop. It will talk about the trends and opportunities for 6G systems. Let me talk about 6G systems because 6G will be a very huge system that will include all the telecommunication facilities that are going to be working under its umbrella. Our agenda today, we will talk about what's 6G and its key technology, targets, application, and the roadmap to be deployed. First of all, as you know that we have starving users for using huge amount of data rates and data or video communication or browsing or downloading, all of these, whereas they are moving around. So we are going to have some we can call broadband mobile application service. This was one of the main objectives for the 5G. The 6G will elaborate the concatenation between the mobile broadband services as well as the facility of high-speed vehicles, as well as the integration between satellite layers, terrestrial layers, aerial layers, and the indoor or fog layer. So the 6G will try to satisfy the customer needs or the client needs from the perspective of high-speed mobility, huge amount of data service, as well as low latency. So there will be a huge amount of challenges in order to have such technology. Okay, the evolution of mobile communication, as you see in this figure, according to this roadmap or time stamp system, we have to go from the first generation up to the sixth generation. The sixth generation, as you see in this item, let me use our laser pointer. We have network capacity will be 1,000 times the fifth generation. And so we can talk about gigabit per second for the end user, because this data rate is for the base station. And so the end user can get gigabit per second data rate. So we have some sort of huge or large or broadband services, as well as more energy efficiency. And so we can talk about the green communication facility. So we have to talk about new spectrum needs, disruptive technology that can accommodate such enlargement in the capacity, as well as the reduction in the used energy. Cell-less networks, we are talking about FEM to cells or I to cells. Those will be very, very hot spots, not looks like a huge amount of cells or huge coverage cells. Also, we can talk about the what we call virtual reality and augmented reality as one of the main aspects of the huge amount of services. Also, we can talk about the energy efficiency solution and needs, as well as the artificial intelligence that will accommodate all of these features in order to improve the energy utilization as well as the network capacity. If we are going to compare between third generation up to fifth generation versus sixth generation, we can see that from the service point of view, in the up to fifth generation, we have mobile communication facility in addition to IoT or Internet of Things connectivity systems. Here we can have this facility in addition to the sensing facility, so we can take more and more smart city deployment scenarios, smart sensors, high-speed vehicles, ITS service, intelligent transportation service, and all of these are integrated under 6G umbrella. From the algorithm point of view, up to the fifth generation, we can go to data analysis. In 6G, AI is one of the main pillars or main points or main items of the 6G. So we have to think about data analysis as well as artificial intelligence of all of its type. By the way, in 6G, we have 3 types of AI. We have machine learning, deep learning, and one new type. It's called federated learning, based on the what we can see and what we can store. And so how could we decide? So we have to improve or utilize or more utilize our system utilities. Coverage. From the coverage point of view, 5th generation are working on maybe on the terrestrial network only, means that the sites on the land and the users are on the land. And from the 6G perspective, as we will see, terrestrial networks as well as non-terrestrial networks, which includes satellite and aerial communication facility. Business. From the business perspective, in the 5th generation, we have public network. And in 6th generation, we can get the opportunity of have public operators as well as private operators. The technology we have in 5th generation communication technologies, and in 6th generation we have communication and the mobile edge computing facility, which will give some sort of computational analysis and technology as well as the communication facility. So 6G will be an enhancement and enlargement of the 5th generation, but adding sensing, artificial intelligence, non-terrestrial, private network, and the computing facility. Okay, we are talking about the new vision. The new vision of the 6G is you are talking about the collaboration between the energy efficiency, adding new service, and improve your spectrum utilization. Because you know, one of the main issues all over the world for the mobile operator is to get spectrum utilized, because the spectrum is the most expensive part of any network expenses, capital expenditures. So we are talking about data rate and energy efficiency. So we need to increase the spectrum. So we have to talk about some modulation schemes or some techniques to elaborate the spectrum, as well as including more data rate, as well as not to consume large bandwidths. From the perspective of the 5G commercial, pre-commercial service up to December 2022, you can see from this figure, if we are talking about the spectra, by the way, in the sub-gigahertz, we have 15%. In the sub-6 gig, which is from 3.5 up to 7 gig, which was called FR1, about 53 or 50%. And the mid-band, which is 1 to 2.6 gig, is the old mobile communication, 9%. Millimetric wave, 9%. The sub-gigahertz is about 23%. This is, as you see, that this pie chart introduces to us that most of the operators are working up to 6 gigahertz, and the less of them are working on the millimetric wave. So we have to increase the amount of operators in the millimetric waves in order to increase the system overall data rate. Because as you know, from the rule of thumb, your data rate is 1/10 of your carrier, or more or less, around. So if you need gigabit per second, you have to use 1/10 of gigahertz carrier. Okay. From the number of rollout status by region, we are here have this classification by August 2022. This is for China, about 68%. All the region is covered with 5G. South Korea and the rest of the world is 3% only. Europe 7%, US about 9%. We are talking about the huge amount of deployment in China in order to elaborate and the deploy of the 5G real network. In order to think about, we have some sort of phenomena called domination of short-range connectivity. What is called domination? What is the meaning of this point? Domination of short-range connectivity. When you are moving toward the 5G from 4G, you are going from the 2 gigahertz up to 6 giga. Now we are moving from the 6 giga up to 30 to 90 giga, or what we call millimetric wave, revolutionary 5G. And in order to have super efficient short range communication, which is called 6G plus, we're talking about 2035 or 2040, we are going to use sub-terahertz systems. So by increasing the carrier frequency, you are increasing the capacity and the massive throughput, but your cells will be more and more small. This will increase the labor of how could you control and manage the interoperability between such huge number of cells. In the case of a previous technology, looks like 3G, 4G, we have macro sites and small sites, and these sites are well controlled, and you don't have such obstacles that you will face in the ultra small with higher capacity system, especially with high speed, because in the high speed you will have very high, very large velocity, and you can have so many cell crossing problems, or what we call handover drops. From the mobile telecommunication spectrum, as we are talking about the spectrum, because if you are talking for any new technology, you have to think at first in the spectrum facility. If you don't have spectrum, please do not talk about this technology, because the spectrum is our cable. If you let me say that, your spectrum in any technology in wireless communication is your cabling system. If you don't have spectrum, you don't have cables, you don't have connectivity, you don't have technology. For the first time, we are talking about the first generation, second up to fifth and sixth. We have in 6, we have 2 bands, 7 to 20 gigahertz, and this including, as you know, the satellite band, because we said that the 6G will integrate satellite communication. In addition, 6G will have sub-terahertz, which is a modern version of what we call hotspot coverage, or dense hotspot, or super extreme hotspots that will give you huge amount of data, maybe terabit per second per hertz, and this per second, sorry, and this will give you huge throughput, but in price of, as we will see, some obstacle, and we can discuss it later. Okay. Spectrum characteristic from 2G up to 6G. This is written in range, and as you see here, latency, bandwidth, sensing accuracy. Okay. In case of sub-terahertz, the sensing accuracy, which is one of the main features of 6G, it will be very sensitive, so you can predict your location, you can predict your customer, you can improve your latency, 0.1 millisecond, and you can have huge amount of bandwidth, and but in price of very, very, very short range coverage. So if you are going to high data rate, high spectrum bandwidth, you have to think about very, very short range communication facility. So you have to, in order to cover maybe 1 kilometer square, so you have to maybe 10 to the power 5 sites, which is very large number of sites. On the other hand, in case of 2G or 3G, for 1 kilometer square, maybe one site is more sufficient. But you will have small bandwidth, large latency, very bad sensing accuracy. In order to have the pros and cons, or the positive or negatives of the 6G for the above 100 gigahertz or sub-terahertz frequency, the positive item: large bandwidth, short latency, massive spatial multiplexing, extensive beamforming, because the beam is very, very short, so you can make some any arrangement in your MIMO or massive MIMO array. You can produce what you need of the beamforming shape. The limitation or the contradiction or the drawbacks of this technology: you have very large attenuation, maybe blocked by very, very thin materials, because this material will absorb the energy, and so your signal cannot penetrate the walls, and you have to think about walls or partitions can destroy your coverage plans. All of this including comes from very, very high path loss. Okay. If we are talking about 5G advanced and 6G timeline, from this shape, you can see that from the first orientation or first announcement of the 5G, we will have 3 non-cooperative organizations: IEEE from the research perspective, ITU from the regulatory perspective, 3GPP from the operator and the vendor perspective. Starting from 5G, all of these firms or organizations are united into one roadmap, and can now say that in the 3GPP, third generation partnership project, we will have maybe released 20 by the end of 2026, and this will be the first rollout of 6G. So we are going to 6G in order to achieve all of these facility by means of the cooperation between 3GPP, ITU, and IEEE. If we are going to what is the main difference between first generation up to 6th generation from different perspectives. First of all, let us talk about the application. If we can see this figure, from the 2nd generation, we have maybe as an example, text messages and voice messages only, no more, no less. By 3G, we are including multimedia applications such as video communication facility, high-speed data, and 4G, we have mobile TV, mobile internet, mobile ePay systems, HD video transmission, as well as the existing voice communication. On the 5th generation, we have ultra high definition videos, wearable devices, vehicle to X or vehicle to everything, smart city, and the telemedicine and IoT. From the 6G perspective, we have new applications such as space tourism and fully automated cars, fully connected cars, holographic, because if we have holographic, we can in place of using this facility of online meeting, we can use some holographic if we have enough technology, enough bandwidth, enough data rate, and all of us can be collected in one virtual area or physical area by holographic manner, and this will be one of the main feature of the application of 6G. From the network characteristics perspective, if we are going to talk about the 2G, we will have only circuit switching for voice and the elementary establishment of the packet switched data. In the 5th generation, we have packet switching and the cloud and software virtualization slicing. But in 6G, we have what we call intelligent services, as well as virtualization and softwareization. From the technology development, or what we call access technique development, starting by the amps or FDMA in first generation up to TDMA in the 2nd generation, CDMA, up to 5th generation with NOMA and the massive MIMO. But in 6G, we have quantum communication on the quantum computing, sub-terahertz communication. We have WAM multiplexing, we have blockchain, we have what we call IRS or IIS, which is called reflecting intelligent services, or reconfigurable intelligent service. This will make some sort of increasing the data rate as well as the modulation speed. From the KPI perspective, now you can see from the left side, we have in the 2G, we have about 50 kilobit per second. Up to 6G, we will have 1 terabit per second per user. The delay is 300 milliseconds, and now the delay is about 10 to 100 microsecond. So this will be very good for remote surgery, remote control, management system, and the virtual office. You can do this because you will have a small latency, maybe similar to the physical cable delay. So your system will not be out of phase of the what's happened in the service area with respect to the control area. Also, from the device per kilometer square, we were in third generation about 10,000. Now we have 10 million device per kilometer square. Also, from the energy efficiency, we have energy efficiency parameter maybe 100, and have a spectral efficiency up to 15, which was not achieved or maybe studied maybe in third generation or second generation. The first of all, it comes to alive in the fourth generation in 2010. From the radar shape to compare the 5G versus the 6G, you can see that the 5G in red and 6G in purple. You can see that 6G will enhance the data rate, enhance the data throughput by introducing the visible communication facility, VLC, visible light communication. By introducing visible light communication, you can use sub-terahertz or maybe terahertz itself as a carrier, so your data rate will be enlarged by 100 maybe with respect to the millimetric wave. So also the light will have small latency, and the mobility will reach up to 1,000 kilometers per hour, and the big data rate may be 1 terabit per second. From the KPI of some 6G use case, we have 3 main use cases in 6G: experience sharing, remote control, connecting everything. Because the man or the human beings are dreaming with connecting everything, and they can control them, and you can make some sharing with your colleagues. If you can achieve these goals, you have to take that we are using the dreaming technology, which is called 6G. If you are talking about the experience of sharing, you can move from in the 5G 100 megabit per second maximum up to 1 gigabit per second per user. The telepresence, which is called the holographic algorithms, you can use air interface latency small, and so you can use what we call the telepresence or holographic meetings, or events, or festivals, or everything. Remote control may be used for health application, industrial force, industrial revolution, IR4, and unmanned mobility. This comes from you have very small latency, very large data rate, and very reliable communication facility. So you can depend on this facility. Also, we have to connect everything by means of we have a spectrum efficiency. We have enough spectrum by introducing the VLC. We have a huge number of connected devices, and then we have some sort of energy reduction techniques based on, and this can achieve to you or give you the energy efficiency solution. This table I will let you take a look a bit. This is some sort of what we can summarize what we are talking about, the difference between the 5G and 6G KPIs. This is very important for researchers because if you are talking about the research and somebody you are promoting new algorithm or new technique, you have to check that your outcomes are fulfilled with these required or improved. But you don't think that your research or your paper will be accepted if you are talking about 6G and your latency is 1 millisecond or 2 milliseconds. So this is out of range of the 6G pre-described standards for KPIs. And the 6G goals, main goals, it's as we said, that the integration of the space, aerial, terrestrial, and the maritime communication into one robust network. A large range of application looks like AR, VR, telepresence, autonomous vehicles. And we have so many open research issues related to 6G networking and connectivity. This figure is very important because it is called ubiquitous 3D coverage. We have here so many layers: space layer, which is including LEO satellite, GEO satellites, quantum repeater. We have here aerial network, HAPS, high altitude platforms, quantum channel, and UAV and manned vehicles, and terrestrial network, which is looks like what we have here, is a mobile communication facility, and undersea network by means of ultrasound communication facility. All of these layers are concatenated and working back to back by means of 3D coverage solution. And this is another shape in order to give you some sort of perspective or illustration of the system. 6G has many innovative aspects. If you are talking about, as we said in the last slide, 3D network architecture, we have one of the main challenge, how to model the topology and optimize the energy efficiency between such different layers. And one very special issue about the security and intrusion prevention, because if you are talking about this huge network, these heterogeneous connection techniques, so your security is at risk, as well as you are doing some of your calculation or computation at the end user side, so which we call MEC, mobile edge computing facility. And so your system integrity or system security are exposed to intrusions from different sniffers or sniffing techniques. Also, if we are talking about the lower cost operation for massive dense deployment, we have some sort of challenge, the high performance for physical and the MAC layer. We are using about for this some sort of advanced communication facility, looks like index modulation over dense QAM under NOMA. This will give you a large amount of spectral efficiency, and you can avoid the cost and the spectrum needs, excessive needs for your application. From the perspective of the green communication or energy saving system, we are encouraging the 6G, the energy harvesting modules, and so we need to integrate the energy source as well as the reduce the required energy bit per second. This comes from some sort of using codes or pre-coding schemes, which will give you some discrimination facility in order to distinguish between your received data from the contaminating environment. If we are moving toward the trends of the 6G, as we said, we say have 6G radio system analysis, we have power consumption, we have to think about the semiconductor technology for terahertz. This is some sort of challenges for 6G. Phase array module design, some sort of state of the art. This may be published in last January 2023. D-band 110175 gigahertz phase array modules. Backing trend for 6G. Backing means for the IC development itself and how put it back. Low loss materials for millimetric waves and terahertz, because as we said that the terahertz and millimetric waves have huge, so we have to be care about the attenuation in the system itself. So we have to think about the low loss material, and this is some sort of metallurgy design. metamaterials in order to improve the reception and transmission. And this is some sort again of the 6G technology. If we are talking about sorry. Okay, let us if we are talking about the key objectives to be considered when designing the radio system, we have to think about 3 pillars: the performance, the cost, the power consumption. If you are talking the performance, you have to think about the achievable data rate, which may be up to 100 gigabit per second for the concatenated link. And the coverage will be how many meters or how much sites needed to cover your area. From the cost, you have to think about the cost-effective solution in order to decrease the total cost of ownership, which will decrease the tariff or the charging rate of your service. And then you can encourage so many customers to join your facility. From the perspective of the power consumption, we have to use some sort of special components in order to reduce the energy inside the system, or reduce the energy consumption, as well as increasing the deployment of the AI or machine learning in order to decrease power consumption by adding some software features. Bottlenecks in the terahertz region. If we are talking about the terahertz research and deployment scenario, we can think that the terahertz, you have a very big problem in the link, because the link is very short and not robust enough against rain, and it's not available all over the time because of the blocking and weather change. Also, the bandwidth up to 100 gigabit per second maybe have some sort of shots, or what we call frequency selective fading problems. So you have to think about this point in your research. Also, the spectral efficiency, because if you have large spectral efficiency, you need to pay a lot of energy, and on the other hand, you need to have energy saving from the point of view. So you have some contradiction between large spectral efficiency as well as energy efficient solution. Also, at millimetric wave, especially when we going or immigrate toward the terahertz, the biggest bottleneck is to generate sufficient power to achieve the same link coverage. So we are talking about massive MIMO systems, or IRS, intelligent reflecting service, in order to act as virtual amplifier in order to compensate the attenuation that caused by huge frequency range, but in order to make it looks like the millimetric wave coverage plan. So we are talking about how could we achieve cost-effective as well as high-performance hardware technology. The key activities and future roadmap for the 6G, as you see from this beneficial roadmap, this is looks like the 3GPP one, but the add value here is putting some flagships into based on the operators or the countries' research and development plans. Also, some of the main vendors looks like Nokia and SC, because they are have a very huge amount, especially with NTT from Japan, in order to achieve the 6G by 2030. The main key enabling technology for 6G from the perspective of ubiquitous 6G networks: terahertz communication, holographic application, cell-free massive MIMO, which is called CF-M MIMO, reconfigurable intelligent service, or what we call, in other words, intelligent reflecting service, non-terrestrial networks, and we will talk about this shortly. Zero energy communication. This is some sort of dream, but we are aiming to have minimum energy consumption system. Finally, intelligent and high secure networks, because as we said that by integrating more and more heterogeneous devices and put some of your computational power at the edge, on the edge of your network at the user end, so you have to take care about the high security and the possibility of intrusion. So you have to think about intelligence edge computing, artificial intelligence, and how could you defend your network and avoid this. Maybe by deploying some sort of blockchain algorithms in order to identify your actual or registered customers to use your network, and on the other hand, you can trust them and send to them the calculation you are need to do to be done by their processors, and then you achieve cost-effective solution and lower energy consumption. Challenges regarding the semiconductor in terahertz. This is a slide I bring only for the guys who are working on the field of metamaterials or semiconductor analysis or VLSI, because in the terahertz your conceptual design is completely must be reconfigured, starting from the gap in the terahertz, because your spacing between the molecules is very short, and this is comparable to the terahertz lambda. Also, sorry, the IC design environment for terahertz is very, very sophisticated. So you have to think about how could you avoid much impurities. Also, the packing itself, which used in the case of terahertz, you have to think about new materials, looks like INP or gallium arsenide or gallium new. Key elements in radio design. If you are using radio environment, you have to think about digital components, power amplifiers, and software features. From the perspective of digital components, you have to use chip partition. From the power amplifier, which right semiconductor to be used, and packing. From the software features, you have to use AI and its family in order to get the suitable algorithm for your software feature. This is a comparative case study, real case study that had done by collaboration between Vodafone and Ericsson in September 2021. They deployed the special model 32 by 32 massive MIMO system, and they compared to the 64 by 64 massive MIMO system. They compare the required power by the regular system, which was 450 watts, and about 50% of it has been reduced to get the new model. This is but the problem in this case of massive MIMO systems, as in the right picture, is like
you speak English with confidence, even while speaking to large groups of native speakers. Imagine what that would feel like, communicating in a way that your audience easily understands and respects.
Okay. The power consumption is going to be half by introducing such technology, but in price of the increasing in the weight itself. The weight of the system is about 60 kilos, and you say that we are telecom engineers. No, sir. If you are doing about the talking about the deployment or rollout, you have to think about the civil works as well as the telecom works. One of the main hot topics in the 6G is the Open RAN technology. What is Open RAN? Open RAN is one evolving technique, comes from the traditional RAN. RAN means radio access network. As you see in this figure, traditional RAN means that you have RRH or remote radio head fiber, and this is BBU, baseband unit, RRH remote radio head, fiber connected, and then this BBU connected to the evolved packet core network. Second stage, if we are using centralized network and distributed network and then remote radio head. This case, you can use multiple heterogeneous devices working at the same CU and have and has its own DU or RU, which is radio unit. On the Open RAN, we have all systems are different, and we are not stacking on a certain vendor or certain technique. So we can use different ORU, okay, open radio units, independent from the type or model of the BBU. And so this is the introduction of Open RAN. You may ask me some question. What is the need for such Open RAN? The Open RAN give you the opportunity to have antenna from certain vendor, software from another, and the base station from another. In the current situation, all the operators are claiming that they are not happy by having antenna, BPU, or base station, and the remote radio head or the RF stage from the same vendor. So this vendor can control his or her business. By the Open RAN concept, nobody, if you don't give me this antenna type, I can bring it from any other vendor and it will work. Because of what? Because of the Open RAN. So the Open RAN is a very good solution and the cost-effective one, and it needs more elaboration and more investigation in the field of inter-signaling plan between different different vendors for base stations, antenna, and software, as well as the interface between them. On the other hand, the security is one of the main issues of the Open RAN, because some guys, maybe a sniffer or a hacker, put you artificial site. It is called the man in the middle, or open BTS. This open BTS will act as a real BTS, and they can absorb or register all of your data over there. So if we are talking the Open RAN, will have cost-effective solution, reconfigurable network shape, very good approximation for the reality, but on price of be exposed to more intruders in the system. When we want to take a look about the phase array antenna module design for 6G, you have to think about from this perspective. You have to think about increased throughput, enhanced energy efficiency, minimize footprint, means that the area of the antenna itself, and the cost-effective solution and the scalability to absorb or to be tuned to other dimensions. Also, we are talking about now the smart cities. 6G will accommodate the massive digital twinning for smart cities by creating virtual representation of the real world and using utilized advanced modeling techniques by means of machine learning, deep learning, federated learning, in order to enhance the concept of digitization and the complete digital transformation. Digital transformation means you have to change all of your facilities and documentation and services into digital manner. So you have to get and operate and use of very, very powerful and reliable communication network, which is called 6G. This finally the 6G key application. As you see in this figure, wireless congestion, precise positioning by means of accuracy, energy harvesting, extreme connectivity, and terahertz. This taxonomy for the different key application, you can get it when we send to you the presentation. The non-terrestrial network, as you see in this figure, the intercommunication between public defense and emergency or safety, as well as base station units, all of them connected to each other, and this can be found suitable enough for different application, and the 6G can accommodate different layer of telecommunication facility. Intelligent reflecting service, we have three main types of the reflecting service. From the perspective of the operation, we have three. We have passive, means that when you the light or the RF incidents on this surface, it will be reflected in a certain way. The active, that will absorb the incident ray and do some processing in order to amplify its amplitude and then reflect it again. The hybrid one is a combination between the passive and active one. From the deployment scenario, we have three deployment scenario. We have outside, we have inside, we have indoor, and all of these needs need to be investigated, and many research are done nowadays in order to achieve optimal performance by introducing such intelligent reflecting service. From the vehicle connectivity perspective, we are talking about what we call our dream of total towards fully automated society at 2030. We will have here wireless convergence. We have high capacity. We can accommodate AR, which is called augmented reality and virtual reality. Also, we have some sort of autonomous operation for cargo in the seaports of shore seaports, interoperable process, and a lot of machine-to-machine communication in the inventory system, looks like Amazon area. If we need to sum up what we can talk about, this is the key milestones to jump from the 5th generation to the 6th generation by 2028. We need to increase the bandwidth. We need to increase the data rate by means of more and more investigation in order to achieve the best. Finally, I hope if you have any question, please ask me. I am sorry for being for having such presentation time.
Thank you so much, Professor Dr. Hesham, for the interesting and valuable workshop. We have a couple of minutes for questions to Professor Dr. Hesham.
Thanks, Dr. Hesham. Are there a standard for 6G put now in the IEEE, or this is a proposed?
Practically speaking, now on the 3GPP, if we can return back very fast to the roadmap, yes, this, as you see, this the combination of the 3GPP and IEEE and the ITU, we are here. We are in the release 17, okay, under development. 6G will comes on the release 19, as I said before in this slide. If I go back, please. Sorry. Okay, now we are here. Okay, we have release 17 already under development. Release 18 is still not developed yet because we have some sort of problems between the matching and the operation. Okay, if we are talking about the 6G will be studied in this 2025. So why I'm talking about the 6G? Because this is a lot of research are now open for you and your colleagues in order to achieve the elementary or starting introductory units to elaborate the 6G standards. So as you know, the technology is beyond research. So from the research perspective, now we are working on the 6G, but the deployment perspective, they are working on the 5G. Okay.
Okay. You said that the millimeter waves for communication have a massive problem about large places or sending
Short range, yeah, it is short range communication due to the large attenuation facility. Okay.
Can we change the type for communication, like using light or something
Yes, in
else?
the 6G already VLC is introduced. Visible light communication is introduced in the system in order to achieve high data rate and not to pay spectral renting prices or cost per year for the system.
Also, from the perspective of electronics, the devices has a large or a big challenge when we move to millimeter wave electronics.
Yes.
There is
I mentioned this. It will be a great problem or a huge problem in the case of terahertz, because as Your Excellency said that in the millimetric wave you are facing a lot of problems because as you see, if you are going to high frequency, the metal itself becomes reflector and its capacitance will destroy or damage your design. On the other hand, in the terahertz deployment, the problem will be maximized. So new materials are studied nowadays in order to achieve stability in the operation for the terahertz system.
I see that they change the CMOS technology to gallium nitride technology.
Yes.
Use some material. Thanks for this valuable presentation.
Thank you, sir.
Any other questions? Thank you so much, Professor Dr. Hesham. We are happy to have a nice workshop with you. Second now is the time for Professor Dr. Ruwaida.
Okay, Dr. Ruwaida is now here, but she has some sort of cold, and we hope to hear to be to get back soon. Now Dr. Ruwaida was us, but she told me that she cannot present her point. Maybe later she can give you the presentation. But if you need something from it, I can help, because today she got cold and she have some sort of fever or something. So we hope to hear recovery from that flow.
We hope for her a safely recovery.
Yes. And now I can give you, if you need some sort of discussion in the preliminary, because I know that we have only 10 minutes in our workshop. If you need some discussion with me, I will be happy